Welcome back, everybody. We got lesson 2.2. It's going to be all about for loops and what they can do to make your programs a little bit better. Okay, so first we're going to talk about two types of loops, okay? And I'm talking about these two because they're the main types that we're going to see. So the first one, let me get my pointer going here. All right, so we have a control structure that will repeat code by a defined or an undefined amount of iterations, okay? That's important because we can set a loop to loop a certain amount of times, or we can set it to exit given a certain condition, okay? And what I mean by that is we can set it for like the user to end it or something else to trigger it. It doesn't just have to be it's going to run 10. You know, the program, the user experience can dictate how much it runs, okay? Now the defined loop is our for loop, okay? We create a variable, we set it to a value of 0, and we set a limit. Okay, so we're at 0, we're going to up to 10, and we're going to go in plus 1 until we get there, okay? And we're going to break down this initialization just a little bit more, okay, in the next slide. So it repeats code a predefined number of iterations. A while loop, on the other hand, is a type of loop that repeats code by an undefined amount of time. Now, that's a little misleading because I can make a while loop to be just like a for loop by making a counter and saying that once it counts to a certain number to exit. But if you're going to do that, then just make a for loop, right? While loop should really be used when something else is going to trigger the end of the game, or when you don't know how many times it needs to run. Okay, so how do we actually make a for loop, right? You need to do three things. You need to initialize a variable. You need to set a condition. And this condition is very important because your for loop will not stop looping until this condition is false. Okay, so as long as this condition is true, it'll run. And then you need to increment or decrement. Okay, and how we do that is with the increment and decrement operator. Okay, if we put plus after I or whatever variable, it'll just add 1 to it. So it's the same thing as going I plus equals 1. It's just a little bit shorter, easier to read. And you can use this anywhere. You can use this, doesn't have to be in a for loop, okay? Or you could do I minus, which is the exact opposite. It's like doing minus equals 1. So just take one number off the top after each loop. Okay, so let's look at what those two loops would look like, right? So you can see here we create a variable in I equals 0. Now you see that I'm going to use I a lot. It does not have to be I. You could have called this anything you want, like normal. But generally, I see a lot of people use I, okay? So I starts at 0. This goes up to 10. Well, it goes up to 1 minus 10. And I'll talk about that again in a second. And then we're going to plus 1. So this should go number 0 on the first loop. And then number 1, number 2, all the way up to number 9. And then when it goes up again, when we get to 10, well, 10 is not less than 10. That's false, so it won't run. So when you start it at 0 and you go less than 10, that'll run 0 to 9. Now your decrementing loop is the exact opposite. Notice how this time we started it at 10, and then we said while we're greater than 0. And notice this, we did greater than or equal to 0. So that also works, okay? And then we subtracted 1 each time. So we went down from 10 and we went all the way to 0 because we set it equal to also. So that would have been a little bit more than this one, okay? All right, let's dive in. Let's do some live code. All right, so let's just make some standard for loops. And notice how we don't need anything special to make for loops. They're built in, okay? So you start with the word for, and then you're going to make an int. So int I equals 0. And let's set this one to run a little bit more. I is less than 100, and then another semicolon, and then we'll go I plus plus. All right, so we're going to go 0 up into 1 minus 100, or 100 minus 1. Now you do need braces. These braces are very important. Just like your if statement, whatever code you want to loop over and over and over again needs to be inside these braces. So let's do cout. And let's just start printing off the number at first, okay? Which is honestly one of the most important parts, I feel like, of the for loop is getting this number can be so useful, right? A number that's going to add 1 to it each and every single time can be pretty powerful. And I'm going to do a lot of examples where we use this number inside the for loop, and we wouldn't be able to do a lot of stuff without it. Okay, so let's give this a run, and here, let me get to the right place. Okay, all right, here we go. So let's compile it, and let's just run it. Okay, and you can see, look at that, it went all the way to 99 because 100 less than 100 would not be true, and then we started at 0. Perfect. Exactly what we want to see. Just counting numbers, right? Okay, let's do it the opposite direction. I'm actually going to take off that endl there. And I'm going to do this. I'm going to put, let's do this. I'm going to put a tab like that, just so it doesn't take up so much vertical space. Just a simple hack. Let's see what we got here. Okay. That's not exactly what I want to do. Other slash. Okay, there we go. Now we're talking. Got it nice and neat. Okay, almost nice and neat. All right, let's do this downwards now. In fact, I'm just going to change this one. Let's charge this to 100. And then we got to flip the direction of this because we would have a problem here. If we started it the way it is, I is 100, I is less than 100, that's immediately false. It'll never run. So we need to now talk about it being greater than. I is greater than or equal to 0. And now we need to minus. If I left that at plus plus and it went up, it would always be greater than or equal to 0. We would end up with an infinite loop. Okay, so let's give this a compile and a run. And you can see we're going in the other direction now. We started at 100. And we went down to 0. Okay, so super basic for loop. Okay, and I'm gonna dive into some more examples, but I just want to start nice and easy. All right, so as promised, let's start looking at all these useful things that are unlocked by for loops. For starters, we can easily sum numbers with for loops. We create just an arbitrary variable outside. Okay, something to store the sum in. And then we're going to start at 1 and go all the way to 10, right? Oh, and this is actually wrong. That should just be I, and I'll do that correctly in a live code. But if I would have gone sum plus equals I, not 10, then I would have gone 1 plus 2 plus 3 plus 4, and I would have been able to sum all of these I values and then afterwards print out the sum, okay? This can start to get pretty powerful. Maybe I'm not always adding the I values. Maybe I'm getting something from the user and summing those, right? Pretty powerful stuff, okay? Now, I wrote AI number guessing, right? And this would be the worst, absolute worst AI number guessing ever made, okay? But look at this. We generate a random number, we set the seed for a random number. Then we get a random number. We're taking the mod 10 so that we get, 1 to 10. Okay. Well, then I would run a for loop from 0 to, up to 10. And if it's the number, if I is equal to that special number, hey, I found your number, right? So basically, we're just going to go to every single number we could think of and check if it's the random number. This would work every time I run the program. It's more of a brute force style than something truly unique. But again, we can do something a ton of times. If I want to guess what the number is, why don't I just guess all of the numbers, right? And this, when I say brute force, a brute force attack on hacking your passcode might be trying every single possible, number now, or number of passcode. For you and I as humans, that would be very difficult for us to try everything, but a computer can do this really, really, really fast. Okay. Now, I'm not going to break down the AI number guessing one, but let's break down summing of the numbers, especially since there was a little bit of an error in that PowerPoint. So before in my codes a lot, I kind of have to clean up what happens in main because we only have one method. But now we have multiple methods. So I'm going to, declare, let's call it, a sum method up top. and start putting these in methods so I can just call them in main and kind of organize my code just a little bit better. Okay, so in here we're going to sum, just as many numbers as we want to, right? So we'll make int sum equals 0. And then we're just going to sum the for loop numbers. So for int I equals 0, I is less than or equal to 10, which, in hindsight, if I set this equal to 0, well, 0 plus 1 is just 1, right? So there's no point in starting at 0. So we'll start at 1, and then we'll go and we'll just add 1 to this. Or, let's do 10,000, right? I mean, we got a computer. We could do this just as fast, as 100, right? And then we're just going to go sum plus equals I, which is what I failed to do in the PowerPoint. Sum plus equals I, okay? So every time this loop runs, it's going to take the loop number, the counter, as we sometimes call it, and just add it to sum, okay? And then let's print it out. So C out, and let's start polishing our program. So the sum is, let's do that, okay. And then we'll just give this a call in main. And so now I can leave that method here when we do the next live code and just not call it, okay? So I'm going to compile, run, and look, the sum is 5,005,000. That's a pretty big number. Seems like it's not, like, one could say, like, there's got to be an error there, right? It's such a weird number to get. Well, let's try it with 5. That's something we would be able to verify, right? If it worked. Okay, 15, that sounds, 5 plus 4 plus 3 plus 2 plus 1 is 15, right? So this is working, okay? The computer can do that super, super fast, right? Much faster than a human being could. Okay, let's get back to some other topics. Okay, here we're going to talk about nested for loops, and I hope you're kind of noticing something here. In all the previous lessons, I'm so focused on, how to make a string, how to make an int, how to do an if statement, and we weren't really solving any problems. We were just kind of getting the basics in. How do I get something from the user without getting an error, right? How do I ask the user a question and go left or right? But now we're learning these more powerful tools that can just do all sorts of things, okay? But notice something here. We've used a for loop at this point to sum numbers. We used a for loop at this point to guess every single number, but it's still doing the same thing, starting at 1 and looping a predetermined amount of times. How we leverage that is up to us. Now here we have a nested for loop, which you can nest more than 2, okay, or more. I guess 1 is inside the other. You can nest if statements. You can put a for loop inside of an if statement, an if statement inside of a for loop. You can nest as much as you want, okay? Generally, you don't want to nest too much because then your code just gets really weird, okay? But look at this. I got an outer for loop, as we call it, that's going from 1 to 10, and then, or 1 to 9. Inside, we have another for loop that's going from 1 to 9 also. So every time the outer for loop runs once, the inner for loop runs here 9 times, which we'll change these to be equal to in our actual code, okay? And then we're going to say what the x number is, what the y number is, and then we're going to, take x to the power of y. And we're going to do this super fast, over 1,000 calculations, okay? And then we got a couple more to look at too. But that's something we couldn't do before, right? Now let's look at breaks and continues. These are better for while loops, okay? But I want to start introducing them now, okay? You might have seen this before, a for loop that has no initialization, no condition, no change, okay? Increment or decrement. When you do that with just 2 semicolons, you get an infinite loop, a loop that does not stop running. Now, generally we use those for while loops, right? But here we can do this, okay? There's some overlap. So watch this. Look what happens inside. The first thing we do is we ask our user a question. So now I'm just going to keep asking them over and over and over again. Should I stay or should I go? And if they answer stay, we're going to run it again. If their answer is go, we're going to say bye, and then we're just going to run this statement called break. Break says stop the loop, okay? So notice there's no condition. So now the user, by entering in go, is deciding when the loop ends. Now, if we don't get either of these stay or go, they must have not answered correctly. So, well, we didn't understand your answer, so here we go again. We're going to force them back, and we're going to do continue, okay? Now, continue, in this example is not too entirely necessary, but it helps us start to understand what this is. What continue does is stops the current iteration of the loop and just goes right back to the beginning of it, okay? So, for instance, if in this loop you had a whole storyline after this question, but they didn't answer something right, you could just send them right back to the beginning of your story and go, nope, try it again. This is going to be super important for choose your own adventure games. Okay, and now a user-defined for loop. Well, this is where the user decides how many times it's going to run. So, we ask the user, how many times would you like this to run? We make a variable for input, we store it, and then we look at this, we use it right here in our condition, which is totally fine to do, okay? So, if you're gonna ask the user, tell me how many numbers you wanna add. Well, now they can sit there and go, I wanna add 5 numbers. I wanna add 10, I wanna add 20, and your for loop will get as many numbers as you need. Okay, now I know it jumps right into the QuickCode. I want you guys to see this example run. So let's do a live code real quick. All right, so here I'm going to create a method called nested loops where we're going to run that. So void nested loops, and we're going to create an outer loop, which we're going to use x. So we're going to start it. Let's start it at 1 because we know 0 times 0 is 0, right? And we're going to say x is less than or equal to 10. So we would go from 1 to 10. And then we'll add 1 to x after each loop runs. Okay. Now inside there, we're going to do int y is equal to 1. Y is less than or equal to 10. And then y plus plus. All right. And then we'll start printing out what each number is. So let's do that actually let's do this all on one line. Okay. So let's do, okay, so x is, and we'll print out x, and then we'll say y is, and we'll print out y. And so x is x, y is y, and x to the power of y is, and we'll go power x comma y, all right? Now the problem at this point is I have not included CMath. So I'm going to go back up to the top here, and I'm going to add that include so that I can use that, okay? All right, so x is this, y is that, and x to the power of y is this, okay? Pow xy. All right, and then let's call it in our main method. So nested loops, okay. Let's give it a compile. And let's raise the size of this really quickly. All right, got a lot of numbers. And so obviously I needed to have included a space there. But watch this, look. X is 1 10 times in a row, right? And Y went from 1 to 10 before X ever changed, right? So we can see a loop is running 10 times inside of a single loop. And, first 1 to the power all, we get 1. And now look, we start seeing 2 to the power. So this is base 2. 2, 4, 8, 16, 32, 64. That's all legit. Now base 3. Base 4. Base 5. Look at how fast we're doing all of these types of calculations. It's no secret why we've been able to figure out so much more about math when we've started to point computers at them to verify our stuff or to find new stuff, okay? If I wanted to find the largest prime number ever, it'd be a pretty easy task to give to a computer, okay? So I hope this helps you understand nested loops, okay, a little bit more. And I do actually want to do another example. I want to do the getting the input from the user in a for loop. I think that's super important. And that's kind of how we're gonna use them in our QuickCodes. So I'm gonna call it user input, which I haven't declared it up top yet, and I'll do that in a second, all right? It's not too hard to get it as many things as you want from the user. So let's create just an arbitrary answer variable, set it equal to nothing. And you know what, let's double this up. Let's ask the user how many times they want us to ask a question. So we'll go int limit equals 0. And then we'll ask them, so how many times do you want the loop to run? Okay. And then we'll store that in limit. And now we're going to run our for loop. And we're going to run it based off of limit. And let's start it, generally going to start mine at from 1 to limit. So I'm going to do 1 and then less than or equal to. But 0 often is, important to start there also. And then here again, let's just ask for, just for some numbers. Okay. I don't want to, trying to not give away the QuickCode or give you the answer to the QuickCode. All right, so let's do it. Let's get some more stuff. So let me create just another variable out here, just call it int var equals 0. In fact, let's just call it temp. All right, I like to use temp whenever I don't really need it after. I just need a place to store a number for a second. And we'll tell them to enter a number. Okay. And then we'll store it in temp. And because we don't really care about temp, the value of it existing beyond the for loop, it's okay that it's going to get overwritten every single time the loop runs. Okay, and then we'll just print it out. You entered temp. All right. Let's put an endl on that. All right, here we go. Let's give a declaration for user inputs up top, and then let's call it right here. Okay. Whoa. Undefined reference to user inputs. Oh, okay. So it basically just means that I added an S. It was user input, not user inputs. And so I'm going to recompile it. Awesome. And give it another run. So how many times do you want through? 1, let's start at small 3, entered 1, 2, 3. Boom. I can keep getting the user input. Let's run it 15 times. Oh boy. All right, and it's just going to keep running it. And there we go. Okay. So we can sit there and start, asking the user how many times the loop should run, and even in the loop, get the input that we need for each iteration. Okay. All right. Let's dive into what your QuickCode is going to be. So your QuickCode is a calculator with for loops. Okay. But what I mean a calculator with for loops is starting to use the for loop to our advantage here. All right. So you need to enhance your calculator with the following operations for the calculator from the previous QuickCode. The way you're going to do that is first you're going to create an average calculator. So allow the user to enter in 10 numbers and then average their numbers. Now I suggest using doubles. I suggest using doubles because if the user goes, I want to enter in 2 numbers, right? And they choose 1 and 4. You sum those. 1 plus 4 is 5. 5 divided by 2, because there's 2 numbers, is 2.5. So if you only take ints, you're not always going to have an accurate average, okay? But again, they need to enter in, here I'm putting 10 numbers. If you want to make it how many they want, that's fine too, okay? The next thing is an even odd checker. This is a little bit more tough. Allow the user to enter in a number and print out all the evens and odds from 1 to that number. And here is your big hint on making this work. You need the modulus operator, okay? Now, what I mean by that is if the user enters in 10, you should be like 1 is odd, 2 is even, 3 is odd, 4 is even, all the way to 10. Now, us as human beings, this is a piece of cake. We can hear a number and go, that's even or odd. But getting a computer to identify, what's an even and an odd number is not as simple, okay? And I really want you to get into the mindset of how we have to think like a computer sometimes to solve problems. Now here's an advanced opportunity. It's exactly that. An opportunity is not required to do, but if you want to push the limit, here is your challenge. FizzBuzz, and this is very popular. Allow the user to enter in a number and then print out fizz if that number is divisible by 3, buzz if that number is divisible by 5, and FizzBuzz if that number is divisible by both 3 and 5. So if 3 and 5 print, I should see fizz and I should see buzz print to the screen. Okay, and it should be from 1 to whatever number the user enters. Okay, now this is required. I know it keeps getting blocked here. Let's move a pointer away. Each new operation must be in its own method. And I used a Java term again, function. Each one should be in its own function. So average calculator should be in its own function. Even an odd checker should be in its own function. So we know how to use them now. No longer acceptable to put them in main. Okay. Now, let's show you what this looks like. I actually have an example of all 3 so that you can get started on them. All right, here's your example. So, welcome to my new calculator that does unique stuff, right? Now, I'm asking you to add to your calculator. I've only included the new operations, but this should fit into your other calculator. So choose your operation, average, even, odd, FizzBuzz. So I should have put some space there, but I'm choosing average. How many numbers would you like to enter? Okay, now I did say 10 in yours, okay? I did say 10 in the instructions. So you can choose to make them enter in 10, or you can choose to do it the way I'm doing it. I think it's better to do it this way, but your choice. Okay, so I said 3, so enter number 1. I'm going to do 1, 3, and 5, which we know should average to 3. And I get 3, just like we wanted. Okay, so that's part 1. Now, just a quick reminder, I know I said make them do 10. You can make them do 10 numbers or make them choose. Either is fine. Okay, choose your operation. I'm going to go even, odd, enter a number, and I will check the evens and odds to that number. Okay, so I'm going to say 100. And look at this. 98 is even, 97 is odd. I'm checking all of them, and there is not an error. Okay, now, I've seen people do this in clever ways in the past by just trying to flip between evens and odds and starting at 1. You need a way of proving it so that if I were to just enter in, if we wanted to do it where we weren't just going from 1 to the number, it was more just enter a number and tell me it's even and odd, you wouldn't be able to do that trick. Okay. And then lastly, FizzBuzz, my favorite. So enter a number and I will FizzBuzz to that number. So 100. And look at this. So 3 is divisible by 3, which means fizz. 5 is divisible by 5, so we got buzz. 6 means fizz, right? Now notice when we get to 15, which is divisible by both 3 and 5, we get FizzBuzz. And we should see that again at 30. See that? And it goes all the way from 1 to the number. So if I enter in, let's do FizzBuzz. I enter in 10,000. Boom, 10,000, done. You see how quick that went? Blink of an eye. All right. So I hope this helps you understand what your QuickCode is supposed to look like. Sorry, there was a few errors in this one. I'm going to work on not having so many in the future. But just as a kind of closing here, you're going to start to see these lessons shift more to what are the new types of problems that we can solve with these new structures. We're moving out of the basics. We're moving into problem solving, and that is very important. Okay, so good luck, and I'll see you guys next time.